In this video, I am going to use the chain rule repeatedly to find the derivative of this function, cosine of sine of tangent of x. So this is just a repeated application of chain rule to trig functions. So let's show you how it happens. So let's say your u is equal to tangent of x, okay? And then v is equal to sine of x, v is equal to sine of x, and let's say w is equal to cosine of x. So if you compose these three functions, you will get this function. So let's start off with v composed with u actually. V composed with u of x, which is v of u of x, which is gonna be v of u of x is tangent of x, so tangent of x. Now v takes whatever the input is and applies sine function to it. So there's gonna be sine of tangent of x. At this point, we could take it one step further. We could do w composed with v composed with u of x. So three functions composed together. So now these two we already found right here, which is sine of tangent of x. So the composition of these three is going to be equal to w of input coming in from these two, which is going to be sine of tangent of x, sine of tangent of x. Now, what does w do to the input? It applies cosine function to it, okay? So it's going to be cosine of sine of tangent of x, 1, 2, 3. Now, if you look at it, this is the same as y. So this is equal to y. Now, taking the derivative of it with respect to x is pretty straightforward and easy. So dy over dx. So I'm just going to think of it as cosine of something. So it's going to be derivative of cosine of something is negative sine of something, right? The same thing. So it's going to be negative sine of tangent of x. So let's say 1, 2. So times the derivative of the whatever is inside the parenthesis or whatever was the argument of cosine. So it's going to be d over dx sine of tangent of x. Now we are going to do the derivative of this again using the chain rule. If we do that, this is what we get. So this is just what I have had here. And the derivative of sine is going to be cosine. So cosine tangent of x, and then take the derivative of tangent of x again. So in the next line, I put these two right here. And then derivative of tangent of x is secant square of x. And that's what the derivative of y is going to be with respect to x. This is just a very simple application of chain rule repeatedly, okay? So apply the chain rule again and again as you kind of ripple through this sine, cosine, and tangent, okay? I hope that this discussion was helpful. Thank you very much.